I talked about Java and object-oriented programming in general and what it is. So in contrast to traditional programming, where you might have one giant program that has a beginning and a bunch of lines of code and one exit point, in object-oriented program, you create a number of specialists called classes. And the instances of those classes are called objects. So this class and this class and this class are three distinct blueprints. This class might be a specialist in generating random numbers, and this class might be a specialist in using random numbers to create rhythms in a melody, for example. And this might have nothing to do with either of those two. It might be a specialist in reading and writing audio files to and from disk. But in contrast to traditional programming methods, each one of these guys can have a function in it, or a method, as it's called in Java, called main. And each one of these can be run as a main class, as a program in and of itself. So for example, if this is your random number generating class, then its main method can run a number of statistical tests to make sure that your random numbers are fair. It might throw a coin 10,000 times and make sure that roughly 5,000 of those are heads and 5,000 are tails. If there were a big skew one way or the other, you could run that main multiple times until you're convinced that there's something wrong with the way you're generating random numbers, and then you could fix it. But the point is that this is a self-contained class with its own main method, and you can just tell Java to run this class, and it'll do whatever you defined in the main method. Similarly, you could put a main method inside this class, which generates durations for some melody. And again, you could test it mercilessly and make sure it works exactly the way you want it. And then in this example, this class, this blueprint, writes and reads audio files to and from disk. You could separate that. You could test that separately from everything else. And these classes can talk to each other. So this class, which generates the durations, might reach into this class and ask for a random number. And I might use that random number to generate a quarter note or an eighth note or a 16th note or a dotted eighth note or whatever. The point is that they can communicate with each other. So any method, any verb, anything that's in this random number class that is public can be read by any other class. And if you had a sort of master class that put it all together, its main method could sew all these things together and generate a melody, which in turn uses this random number generator, and play it and write it to disk by calling helper methods in this class. Okay, so that's basically the brief overview that I gave of object-oriented programming. Then I gave an example. And I said, let's design a class. So now we're looking at Eclipse, which is the Java IDE that you should download. It's at www.eclipse.org. Download Eclipse for your platform. It's free, and you get a very, very robust Java development environment. All right, so let's say we want to define this blueprint for a class called city. What does a city have? Our simplified version of a city has a class variable called population, which is of type integer. So this int stands for integer. Integer is a whole number, like -5, like 0, like 1,000. There are a number of primitive classes in Java. There's int, there's double, there's boolean, there's float, and there's char. Those are the primitive data types. Everything else is a class. So we are defining city, which is going to be a new class. And one of the things that defines a city is its population. So every object of type city is going to have its own population. And every city is going to have a name. So notice that int is lowercase. That's a primitive data type. String is anything that can be typed. It's any series of letters and numbers. So, in fact, if I just hover over the word string, Eclipse pops up the Java help definition of what a string is. A string class represents character strings, such as ABC. And here's how you define a string. String str equals ABC in quotes. Okay? So every city is going to have a population and a name. Then we talked about how to access and set those values. So there are methods or verbs called procedures in other languages, but in Java it's called a method, that are called getters, which retrieve values out of a class, and setters, which set values in a class. So let's create the setter for the name. So I'm going to make it a public class, and I'll talk about void in a second. I'm going to say set name string name. Every method begins and ends with a curly bracket. Every class definition begins and ends with a curly bracket. Okay, so public means that this method is accessible to other objects. Void means that this method is not going to return an answer. It is purely an activity. It's not like if you had a method called square root, where you would give it a number and you would expect the square root of the number to be returned to you. So if it's void, it means you're not going to get an answer out. So set name is void because I'm just going to put a string in for the name of the city. Notice that this word name is spelled exactly like this word name. It doesn't have to be. It might even be a little confusing that I used the same word twice, but it illustrates a point, and that is that if I want this name to be set equal to this name, I need to distinguish them. If I were to go name equals name, and in my mind think that this name is this guy and this name is that guy, then I would be making a mistake. And in fact, Eclipse warns me that the assignment to variable name has no effect because of this thing called scope. The scope of this variable name is between this bracket and that bracket. So if it sees the word name, it looks for the context of the smallest scope. So it must, Java thinks you must mean this name. If I want to indicate that it's this name, then I refer to this. This meaning, this is an identity. This is like saying me. This is like saying the name that belongs to this class, meaning the one up here, shall be assigned to whatever value is in this name, which is the parameter. Okay? So this is typical Java syntax. I could have avoided this if I just like called this variable n. Then this would be unambiguous. The only name in this context is this guy, and the only variable called n is this guy. But I like using variables that stand for that sound like what they stand for. So I'm going to use this technique. All right, so that's a setter. That'll let me say, here's a new city, its name is Chicago, or here's a new city, its name is New York. Now I'm going to do the getter. So I want to retrieve the value of the city as well. So the name, retrieve the name of the city as well. So it's going to be a public method. This will return an answer, and it's going to get the name of the city. And here, all I need to do is return the name. So return is sort of like export or spit out or give out. Or if you want to get the name, you have to send a value out. And return is the verb that is sort of equivalent to this notion of sending a value out. So you could just say, print mycity.getName, and that will be the equivalent of saying print my city, my city's name, like Chicago or New York. All right, so this is the getter, and this is the setter. Then I left as an exercise to the class to write the getter and setter for population. So you can try doing that now. Pause the video and see how far you get. And now I'll write it for you. So to set the population, I'm going to write public void set population int population. And I'm going to say this dot. Notice that Eclipse will autocomplete for you. So I just type the letter P, and it suggests that I mean population equals P. And I can hit Control space, and it'll autocomplete that for me as well. So that's set population, and then the getter is going to be public int get population. I'm going to return population. Pretty good. So now, this is a blueprint for a city. I can create one, I can create two, I can create three. Each can have their own name, each can have their own population. So let's actually test it. As I mentioned earlier, each class can have a main method. The main method is what will run if you ask Java to execute that method. So execute that class. Eclipse lets you shortcut the writing of a main method by typing in MAIN and then hitting Control space, and it will write that main method for you. That's the headline. That's the signature of the main method. I talked about static. Static is a special word that describes a variable or a method as belonging to the class, not the object. So in other words, you can have 100 different instances of a city, but the main method is uniquely the same for each of them. Void, you know what that means. It doesn't return an answer. There's the main method. String args means this is an array of arguments which are optional. Like if you wanted to run this at the command line, you could tell Java to run city, and then you could add 2 or 3 or 4 values at the end of your command line, and those 3 or 4 values would be rolled up into an array that you could retrieve. We're not going to do that here. So let's create a city. Let's say city1 equals new city. So there's a lot here. So I've declared a variable. I call it city1. It's of type city, so it's one of these things. It's one of these things that we designed here. And it is equal to new. So new means allocate memory for, create a new object of type city. These open and closed parentheses, that indicates a special method called a constructor. So when later we'll see how you can use constructors, but for now just suffice it to say that city is created with this new method, and we're putting the parentheses after the class name to indicate that we want to run the sort of plain vanilla constructor that gives us a new instance of that city class. So city is a class and city1 is an object. Okay, so that's the difference. The class is the blueprint and the object is an instance of a class, a living version of that class. So now we can talk to city1. We can say city1 dot set name, and in quotes I can say Chicago. And I can set its population. I can say city1 dot set population 2.7 million. Oh, I can't use commas. Someone actually looked this up for me yesterday. Note, you could also do a calculation. You know, it'll resolve expressions. So 2.7 times a million would work, except that's not an integer, so you would have to actually cast that to an int. So I'm getting ahead of myself here. But anyway, let's go to 0.7 million. Command-Shift-F formats your source code nicely. So if this gets all weird, you can hit Command-Shift-F, and it'll take care of all the indentation. Okay? And then I could do the same thing for city 2. I could create another city, call it New York City. I don't know what the population of New York City is, but this is how you would do it. I've got a cat who wants to walk across my keyboard right now, so I'm a little distracted. Then I also asked the class to do an exercise where write an expression that doubles the population of city 1. So think about that for a second and see what you come up with. Pause the video and then try it. And here's how we did it. City 1 dot set population 2 times city 1 dot get population. Make sense? All right. If you actually wanted to see this, you can say system out print line city1 dot get population, and we could do it before and after. So I just copied and pasted that. And you could do this before, after. Notice that strings and the plus sign is just a simple concatenator. So if you're expecting a string, you can just take a string and add it to an integer or another string, and it'll just create another string. All right, now in Eclipse under under Run, you can go to Run as Java Application, and this program will execute. And off screen, we got this before that and after that. All right. The class also, I did some demos. I did some demos of Syntona. So you should be looking at Syntona and a couple of the videos that I posted on YouTube about Syntona. There's a bunch of examples in there. I also showed a couple of demos of musical pieces that it's not really going to translate too well to this medium. So this is just a brief overview of the material that we did, and I hope it was helpful.